Hello everyone, I am Genevieve Bonifacio, your instructor for today. Mathematics in Modern World. Patterns in numbers in nature and the world. Patterns defined as regular, repeated, recurring forms or designs, identify relationships, finding logical collection to form generalizations. Patterns in nature are visible regularities of form found in the natural world. These patterns recur in different contexts and then sometimes be modeled mathematical. Kahit saan tayo tumingin o pumunta, marami tayong makikitang patterns. Halimbawa, ang bawat design ng skyscrapers, yung layout ng floor tiles, at kung paano tayo magsintas ng sapatos, at marami pang iba. Natural patterns include symmetries, trees, spiral, meanders, waves, forms, descelations, clocks, and stripes. Study in pattern helps students in identifying relationship and finding logical collection to form generalizations and make predictions. Here are examples. Number 1. Which of the figures can be used to continue the series given below? From the left to right, the arrow rotates each column 45 degrees clockwise, so the answer is letter D. Number 2. Which of figures can be used to continue the series below? In the series of pattern, meron tayong tatlong objects, the black square, circle, and arrow. Isa-isahin natin ang movement nila. Una, yung black square. Nag-move yung black square natin from the left to right sa bawat row. Yung susunod na movement niya ay dapat nasa lower right corner. Nasa choices natin yung apat na choices. Lahat na black square ay nasa lower right corner. Hindi pa natin ma-identify ang sagot. So, next natin ay yung circle. Yung movement ng circle is in the clockwise direction from the left to right. Ibig sabihin, nasa lower right corner din ang position ng circle. Sa pagpipilian natin, merong sa A and C lang ang both the black square and circle ay nasa lower right corner. So, ibig sabihin, isa sa kanila ang tamang sagot. Para ma-identify natin yung tamang sagot, yung pangatlong object ay magsiset up ng tamang sagot. So, therefore, letter C ang tamang sagot. So, for number 3, which of the figures can be used to continue the series given below? Dito, meron tayong box, upper box and lower boxes. Observe ninyo yung first, third, and fifth. Upper box, lahat sila yung tatlong yan ay merong tig-6 na dots. Ibig sabihin, ang pang-7 ay meron ding 6 na dot. So, dito sa choices natin, yung letter B and C lang ang merong 6 na dots sa upper box. Next natin, titingnan yung lower box. Kung yung first figure merong 2 dot, at yung third figure merong 3 dots, at yung panlimang figure merong 4, ibig sabihin, yung pang-7 figure niya ay meron ng 5 dots. So, dun sa lower boxes niya, between B and C, si C yung may merong 5 dots sa lower box. So, therefore, the answer is letter C. For number 4, what number comes next? 1, 3, 5, 7, and 9. So, each term is 2 more than the previous term. So, therefore, yung susunod na number dyan, who is Leonardo of Pisa? Saan ba nanggaling at nagmula ang salitang Fibonacci? Okay, by the way, ang salitang Fibonacci is a nickname ni Leonardo. So, Fibonacci is the greatest European mathematician of the Middle Ages. He was born in 1170 and died in 1240. He introduced the Arabic number system in Europe. Okay, let's discuss the origin of Fibonacci sequence. Okay, saan nga ba ito nagmula? Nanggaling ito sa pair of rabbit. Fibonacci sequence was discovered after an investigation on the reproduction of rabbits. Bakit nga ba rabbit? Or how and why? O kung paano? Let's consider this illustration. Problem: suppose a newly born pair of rabbits, one male and one female, are put in a field. Rabbits are able to mate at the age of 1 month, so that at the end of the second month, a female can produce another pair of rabbits. So, consider this as a one male and one female of rabbits. Okay, so nagmamature sila in 1 month. After that, they can produce another pair of rabbits. So, ganun ang scenario. After the end of the month, lagi silang nagpo-produce ng another pair of rabbit. Kung ito, nag-start sila, so after a month, nakapag-produce sila ng isang pares ng rabbit. So, after ng isang buwan na naman, another pair of rabbit. So, ganun yung patterns, kaya meron tayong number of pairs dito. So, ganun yung patterns, kaya meron tayong number of pairs. 1, 1, 2, 3, and 5. Kaya a pair of rabbit ang pinag-aralan, so sila yung dahilan kung bakit nagkaroon ng Fibonacci sequence. Okay, Fibonacci sequence is an integer in the infinite sequence. 1, 1, 2, 3, 5, 8, 13. So, makikita natin na bago mo makuha yung next term, i-add lang yung last two terms. So, kagaya nito, 8 plus 13 is 21. So, para makuha yung next term, add nyo lang 21 plus 13, get 34. So, 55, 89, 144. So, ibig sabihin, 144 pairs will be there at the end of the 1 year. Okay. Fibonacci sequence in nature. So, paano ba natin mararelate si Fibonacci sequence in nature? Or how can relate Fibonacci sequence in nature? So, pwede ba natin marelate o makita si Fibonacci sequence in nature? Yes. For example, sunflower. Okay, Fibonacci spiral in sunflower. Makikita mo dyan yung, or you can try to observe the spiral structure of the sunflower. So, this is the example of Fibonacci sequence in nature. Another example is the fine cones. Here. So, you can see the Fibonacci spiral. So, tingnan natin yung arrangement ng balat ng fine cone. So, here are another example. And here are another example of Fibonacci sequence. Tanong: can plants do math? No, but their growth is based on this sequence. Okay, we can relate the another one is the golden ratio. It is also relate on the Fibonacci sequence. So, ano ba yung golden ratio na yan? In this video, we were going to talk about the mathematics. The golden ratio. The golden ratio is often denoted by the Greek letter or pi. This is approximately equal to 1.618. The golden ratio can be expressed as the ratio between two numbers. Here are the formula. A over B equals A plus B over A. So here are the illustration. The golden ratio in nature, for example, Mona Lisa, Notre Dame Cathedral, or Parthenon. Find the indicated term of the Fibonacci sequence. Find the ninth term. 1, 1, 2, 3, 5, 8, 13, 21, 13, 21, 34. So the ninth term is 34. Okay, next is find the fifth term, 15th term. 1, 1, 2, 3, 5, 8, 13, 21, 233, 377, and 610. So the 15th term is 610. So, for the next topic, the mathematics self-organized patterns and regularities in the world. A lot of events happened around us. In the blink of an eye, several children have already been born. Liters of water have been consumed or thousands of tweets have been posted. For us to make sense of all available information, we need mathematical tools to help us make sound analysis and better decisions. Mathematics has helped organize patterns and consistencies in the world because one must know that there is always mathematics in almost everything in this world. Here are examples of mathematics help organize patterns and regularities in the world. A particular store can gather data on the shopping habits of its customer and make necessary adjustments to help drive sales. So, of course, how mathematics help to organize the patterns and regularities in the world. So as you can see, let's just have an example. So let's make the pandemic as our example. Of course, ang mas mabenta ngayon are the basic foods or basic needs natin. Yung mga food, of course, hindi natin masyadong kailangan yung mga beauty products. Kaya mas ibebenta ng mga tao ngayon or the different foods that are easy to cook. So second is scientists can plot bird migration routes to help conserve endangered animal populations. So for example, sabihin na natin from January to June, dun sila sa Northern Hemisphere, then for July to December, doon naman sila sa Southern Hemisphere. So, ang gagawin ng mga scientists ngayon is since alam nila na nasa Northern Hemisphere sila, simula January to June, pupunta sila doon para matulungan nila yung mga animals na magparami or they will get some animals where to get and to take care of them para naman maparami nila yung uri ng hayop. So for the third one is social media analyst can crunch all online posting using software to gauge netizens' sentiments or particular issues or personalities sa social media. So that's all for the mathematics self-organized patterns and regularities in the world. Mathematics help predict the behavior of nature and phenomena in the world. It is sometimes said that history repeats itself. As much as we can use mathematical models using existing data to generate analysis and interpretation, we can also use them to make predictions. For example, the weather. Kung kailan dadating yung mga bagyo, example for this time, makulimlim sa oras na ito or sa panahong ito. Kaya ang mga staff ng Pag-asa ay gagawa ng paraan para makita kung may bagyo ba o wala. Applying the concept of probability, expert can calculate the chance of an event occurring. The weather is the prime example. Based on historical patterns, meteorologists can make forecasts to help us prepare for our day-to-day activities. They can also warn us of weather disturbance that can affect our activities for weeks or months. Gaya ni Mang Tani, doon sa 24 oras. Sa broadcast niya, sa umaga mainit pero in the afternoon medyo makulimlim at pwedeng magkaroon ng bugso ng ulan. Ganun ang sinasabi niya, and also by that or referring to that, we can prepare for it. Kung may lakad ka, pwede kang dumala ng payong kasi alam mong uulan. And also we can cancel our different activities. Baka kasi may outdoor activity kayo or bonding with your friends, you can cancel it kasi alam mong maulan sa hapon. Astronomers also use pattern to predict the occurrence of meteor showers or eclipses. Para alam natin kung kailan mapapanood yung mga meteor or meteor showers. So in 2017, announcements were made about heavenly phenomena such as the Draconid meteor shower and the Great American Eclipse. They were able to tell when these phenomena would occur and where would be the best places to them. So, ganon yung nangyari o anong oras yung meteor shower and alam natin kung saan maaaring makita yung mga meteor. So, that's it for mathematics helps to predict the behavior of nature and phenomena in the world. So next is mathematics help control nature and occurrences in the world for our own ends. We have demonstrated by means of examples the universe. There seems to be an underlying mathematical structures in the way that natural objects and phenomena behave. While the photographer could capture a single moment through a snapshot, videographers could record events as they unfold. Painters and sculptors could create masterpieces in interpreting their surroundings. Poets could use beautiful words to describe an object, and musicians could capture and reproduce sounds that they hear. The observation of nature as well as their interaction and relationships could be more elegantly described by means of mathematical equations, as stated by astrophysicist Brian Greene. With a few symbols on a page, you can describe a wealth of physical phenomena. It is interesting then to ponder on how mathematics, an invention of the human mind, seems to permeate the natural laws that holds the universe together. There have been instances when a natural phenomena has been speculated to exist because mathematics says so, but no hard evidence have been found to support its existence. Such phenomena were proven to exist only when advancement in technology have allowed us to expand our horizons. For example, in 1916, Albert Einstein hypo- hypothesized, hypothesized the existence of gravitational waves based on his theory of general relativity. This is when ripples are formed in the fabric of space-time due to large and violent cosmic events, very much like with a pebble is thrown in a stagnant pond. About 100 years later, the Laser Interferometer Gravitational Wave Observatory LIGO announced that it found evidence of this phenomenon. Through the use of mathematics, we can also able to exert control over himself in the effect of nature. The threat of much debate over the years, it is believed that unless man changes his behavior patterns are said to indicate that sea level could rise to catos- catastrophic levels as the polar caps melt due to the increase in global temperatures. To ensure the greenhouse gas concentrations are kept the levels that would not interfere with the climate system, the United Nations Framework Convention on Climate Change, or UNFCCC, was signed in 1922 and has 196 parties as of December 2015. To the use of mathematics, man is also able to exert control over himself in the effect of nature. The threat of climate change and global warming has been the subject of much debate over the years. It is believed that unless man changes his behavior, patterns are said to indicate that sea level could rise to catastrophic levels at the polar caps melt due to the increase in global temperatures. To ensure that greenhouse gas concentrations are kept at levels that would not interfere with the climate system, the United Nations Framework Convention on Climate Change, or UNFCCC, was signed in 1922 and has 196 parties as December 2015.
Mathematics has numerous applications in the world, making it indispensable. Whether you are on your way to becoming a doctor, an engineer, accountant, a public servant, or a chef, a knowledge of mathematics will be helpful. This means that math is used everywhere, that every fact alone makes it indispensable and irreplaceable. Math both acts as catalyst and a cohesive agents in order to get work done faster and tie in all the loose ends together.
So, hello everyone. My name is Miguel Tranillo from Betsville A1, and um, now I'm going to discuss about the mathematics in the modern world. So, I have here five topics. which is characteristics of mathematical language, and four basic concepts: expression versus reality, sentences, conventions in mathematical language, and elementary logic. So first, we have here the characteristics of mathematical language. Number one is precise. Mathematical language is able to make very fine distinction or what's definitions among a set of mathematical symbols, unlike in ordinary speech, which is full of ambiguities, innuendos, hidden agendas, and unspoken cultural assumptions. And number two, concise. Long expositions or sentences can be expressed briefly using the language of mathematics. Mathematical language and symbols cut short the lengthy statements and help the expressions of ideas or things in the exact form. Mathematical language is free from verbosity and helps into the point, clear and exact expression of facts. Move on na tayo sa number 3. The symbolic. Mathematical language can describe a subset of the real world using only the symbols. The use of symbols makes the mathematics language more elegant and precise than any other language. For example, the commutative law of addition and multiplication is real number system can be stated in the verbal form as the addition and multiplication of the real numbers is independent of the order in which they are combined. And number 4 is the powerful. Mathematics language is able to express complex thoughts with relative ease. And the next is the devoid of emotional content. So there is absence of emotion from formal mathematics discourse. And number 6 is non-temporal. There is no past, present, or future in mathematics. It is not affected by time. So dumako naman po tayo sa four basic concepts. Meron po tayong sets, relations, functions, and binary operations. So, first is sets. It is well-defined collection of distinct objects. A set is represented by a capital letter and its element is usually denoted by a lowercase. So, example here is A equals 2, 3, 4, 5, and 6. So, kapag ito po na element na 2, 3, 4, 5, and 6 ay ginawa nating letter, it should be lowercase letter. Dapat maliit po siya. Maliit na letter, hindi po malaki. So, ito nga po na um, ang set A is dapat capital letter siya. So, paano po ito basahin? Ganito po. Set A has an element of 2, 3, 4, 5, and 6. Ganito po siya basahin. So, next is, siyempre may symbol po ito. Symbol used in representing a set. So, this symbol na parang E is a element. Pag may nakita po yung ganyan na E, sabihin element ko siya. And ganito na may E na may slash, that's not an element. So, pwede mo po siyang gawing a member of, pwede mo siyang belongs to, or not a member of, does not belongs to. Pwede mo siyang correct. Element 2 is, um, ito niya. Ito. 2 is an element of A. Ganun niya. For example naman, a member of. 2 is a member of A. Ganun. Member of set A. Two ways to describe sets. Meron tayong two ways. The roster or tabular method, and the rule or descriptive method. First is the roster. The elements in the given set are listed or enumerated separated by a comma inside a pair of braces. For example, ito na yung kanina. A equals 2, A equals 2, 3, 4, and 5, 5 and 6. Or A is an element of 2, 3, 4, 5, and 6. As an element of 2, 3, 4, 5, and 6. Ganun po yan. Ito, separated by a comma. May comma po siya. Enumerated. Inside braces. Ito po yung braces. Yan po. Wala pong pointer. Pero makikita mo po dyan yung braces yung paano. Pulong-pulong. And number 2 is rule or descriptive method. The common characteristic of the elements are defined. This method uses set builder notation where X is used to represent any element of the given set. For example, ito, example A. Example, ito yung example na pangalawa, pareho lang naman po sa pangatlo, pero iba lang po yung pagkaano niya, pagka 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 ano yan, pagkasulat. For example, ito, ang pagbasa po nito ay A has an element of X such that X is greater than or equal to but less than or equal 6. Ganun po siya. Pero pareho lang naman po, di ba? Oh, greater than or equal to or less than, and but less than or equal 6. So it means magsisimula ka sa 2 hanggang 6 lang. So 2, 3, 4, 5, and 6. Pwede po yan. Ganito para sa lang sa first na example. So next is the kinds of sets. Dito po meron po tayong mga kinds of sets, which is the empty, the finite set, infinite set, universal set. So the empty or null or void set, from the word empty, empty has no element and is denoted by this sign na may bilog na slash or a pair of braces with no element inside or ganito na na may itong braces na close and open. So number 2 is the finite set. Finite set has countable number of elements. So ibig sabihin may hangganan. Finite is countable, ibig sabihin may hangganan. So number 3 is infinite set. Infinite set has uncountable number of elements. Ibig sabihin walang hangganan. Kaya uncountable siya. So the universal set naman, the totality of all the elements of the sets under consideration denoted by this sign na parang U. Yun na nga. U. So next. So here are the operations of sets. The first one is union of sets A and B. So ito po yung sign ng union U. Pagbasa po niyan is A union B. So ano to? A set whose elements are found in A or B or both. Sila. Parang pwede mo po silang paghaluin from the word union. Union. Paghaluin. So intersection number 2. Intersection of set A and B. Yung intersection po, ito na po yung sign niya. Yung parang baliktad na yun. Yan po. So, a set whose elements are common to both sides. Both sets. So, kung ano yung makikita mo sa A na elements, yun din yung makikita mo sa B. So, para sila. So, number 3 is the difference of sets A and B. So, ito yung sign, negative. Difference, ibig sabihin negative. Negative sign. A minus B. A set whose elements are found in set A but not in set B. Kasi nga, i-minus mo siya. Kung parang magkaiba sila ng elements na nakapalo. So the number 4 is the complement of set A or A prime. Ito ba yung pagbasa po nito is A prime. A set whose elements are found in universal set but not in set A. So the next slide is, so lumako naman po tayo sa relations and functions. So definition of relation is a collection of ordered pairs. A collection of ordered pairs. So ito po yung example. Negative 2, 1, 4, 3, negative 2, negative 3. Usually written in set addition form with curly brackets. At yan po, may mga brackets sila, diba? Yan. So, function. Function is a special kind of relation where every domain x values must correspond to only one range or y value. Example, -2 or 0, 4, -1, 0, 3. Take note, the x values cannot be duplicated while the y value can be duplicated in a function. Yun po. So, take note din na all functions are relations not all functions are but not all relations are functions. Yun po. So, at ito pa yung example number 1 is A equals is A has a element of 1, 5, 1, 5, 3, 8, 3, negative 8, 3, negative 8, 3, negative 8 is a function or a relation. So, ito po yung solution. Number one is a relation because kasi po may naulit kasi yung ano po 'di ba kanina sabi wala daw dapat walang repetition na mangyayari sa relation. So number two is B has an element of 3, 1, 0, 2, 3, 3, 3, 4, 1, 5 a function or a function or a relation po yan. A function or a relation. So ang sagot po is a function. Kasi wala naman pong naulit sa x values, yung mga x values. Wala naman po. So, yun na po. So, next tayo. And ways to represent relations. So, ito po. Ordered pairs x and y, -2, 3, -1, 2, -2, 8, positive 2, 1, 3, 1, 4, 4, 5, 3. So, ito po yung mapping nila. Ano na lang po. Yung ano. Di ba pang relation, may repetition. Ito po. Na dalawa yung 1 tapos doble din yung negative. Ay, hindi. Oo nga. Ayo, tama. Sorry. Yun nga. Pakikitingnan naman po sa table of values. Sa graph naman ito. So, kinds of relations. Ito po ang kinds of relations. One-to-one functions. One-to-one function is a one-to-one relation. Given any value in the domain, there is only one value that can be paired with the given values in the range. So tig-iisa lang po sila dapat. Iisa. 0 to 2, 1 to 4, 2 to 6, 3 to 8. So, many to one relation states that two or more values in the domain share a common value in the range. Parang nag-share sila, parang may nag-duplicate. Nari, itong 1 and 2, nag-share sila sa 6. Ganun po. So, example number 3 naman is one-to-many, not a function. In a one-to-many relation, the value is in the domain is paired with two or more values in the range. For example, itong 3, nag-pair siya sa 2 and 4. So, hindi po yun function. Dapat, pero kung yung y values naman yung nadoble, okay lang po yun. Function pa rin po yun. Pero kapag yung x na yung nadoble, yun na po yung not function. So, the examples of function is this one, number 1. And not a function kasi nadoble po yung x values natin, which is yung 1. Tapos ito yung function kasi wala naman pong nadoble na x values. Tapos ito yung pangapat naman is not a function kasi nadoble yung -5 na x value natin. So, yun po sa relations and functions. So, dumako naman tayo sa expressions versus sentences. So, here, the definition of first is expressions. A mathematical expression consists of terms. The terms of a mathematical expression is separated from other terms with either plus or minus sign. An expression is the mathematical equivalent of an English noun. It is a correct arrangement of mathematical symbols used to represent a mathematical object or interest. An expression does not state a complete thought. It does not make sense to ask if an expression is true or false. So, hindi po siya kompletong information. Kaya, uh, yun po. So, example is 4, 4x plus 7. The sum of four times of numbers of a number and 7 is an example of a mathematical expression. More example used to representation. Ito po yung mga example pa ng expressions. 3, sunod is 5x, sunod is 2x plus 3y, ax plus by plus c, and p minus q time plus m minus n. Sunod is 2 times a plus b minus 3 times 2a minus 4. So, yan po. So, dumakan naman po tayo sa sentences. A mathematical sentence is a combination of two mathematical expressions. It describes the relationship of expressions using comparison operators to form an equation or inequalities. It uses the following comparison operators: equal sign for equations, greater than for inequalities, and greater than or equal for inequalities, and less than for inequalities also, and less than or equal for inequalities. So, a sentence can be determined as always true or always false or sometimes true or sometimes false. So, ganun po siya. And equations use equal sign to indicate equality. For example, 5 plus 2 equals 7, and 3x times plus 2 equals 19, and 2x minus 5y equals 45. Gumagamit ito ng equal sign. So, inequalities describes two different values. Gumagamit po siya ng greater than or less than sign. 18 is greater than 6, x minus 2 is less than 5, and 5x plus 24x is greater than 11. So, expressions versus sentence. Expressions, ito po yung two or more terms separated by symbols. For example, ang symbol ay positive, negative, multiplication, and division. And example of expressions is ito po, 11, 2x plus y plus 3y, and 2 plus b plus c. X squared, 4x plus 11, ax plus b, by plus c. Gumamit po siya ng mga um, symbols. So, sentence use equality or equal sign or equalities, um, less than or greater than, or etc. to show complete relationship. For example, 3 plus 2 equals 5. Equals po siya. And x times 11 is greater than y plus ax plus 11 is greater than y2 plus 20. So, may greater than 1. So, and sunod naman, x plus y equals 7, and ax plus by plus c equals 0. So, ito po, more examples. Y plus 2 plus 1 is an expression. X plus 4 is an expression. 2, 2m plus 14m is an expression. So, we have here the conventions of mathematical language. Mathematical convention is a fact, name, notation, or usage which is generally agreed upon by mathematicians. For instance, the fact that one evaluates multiplication before addition in the expression is merely conventional. There is nothing inherently significant about the order or of operations. Mathematicians abide by conventions in order to allow other mathematicians to understand what they write without constantly having the redefine these basic terms. Imagine if every mathematical paper began with an explanation or premise. So, at ito po yung mga ano ng mathematical convention, yung parang mga ginagamit sa mathematical convention is numbers and quantities. So, numbers are expressed in base 10 unless otherwise noted, using the 10 digits 0 through 9, and a period to the right of one digit is unit digit for decimal points. Also, in numbers that are 1,000 or greater, commas are used to separate groups of three digits to the left of the decimal point. For example, ito po na 1,000,000 equals ito pong 1,000,000 na may comma na. May, parang divide po siya sa kada 3 digits. Tapos, comma po. From the left digits to the left of the decimal point. To the left. Pa-left po. Mula sa right pa-left. So, sa decimal naman po is ito po, 103.25. Ito naman po. So, number 2 example is some other conventions involve numbers. 1 billion, for example, is this one, 1 billion, equals, ito po, 10 over 9. 10 over 9. Pangalawa po is 1,000. Well, represent the ratio of circumference of a circle to its diameter. For example, it will be 3.14.16. And number 3, when a positive number is to be rounded to a certain decimal place are the number of is halfway between the two nearest possibilities. The number should be rounded to the greater possibility. For example, 23.5 rounded to the nearest integer is 24. Kasi yung 5 pag renound off po yan, dadagdag po yan dito sa 23. Magiging 24. So the next is 123.985 is rounded to the nearest hundreds is 123.99. Nearest hundred. The example is negative 36.5 rounded to the nearest integer negative 37. When the number to be rounded is negative, the number should be rounded to the lesser possibility. Number 4 is repeating decimal are sometimes written with a bar over the digits that repeat. Example, 25 over 25 divided by 12 equals 2.083. Yung may guhit po may bar sa taas. Sa taas ng 3. Tapos, 1 divided by 7 is equals to 0.142857. Yan pong bar sa taas ng 14857. Yan po yung sinasabing bar over the digits. So, dumago naman po tayo sa elementary logic, which is the connectives, qualifiers, negations, and variables. Ito na po tayo sa kasi wala. So, elementary logic, mathematical logic is, at least in its origins, the study of reasoning as used in mathematics. Mathematical reasoning is deductive, it consists of drawing correct conclusion from given hypothesis. Thus, the basic concepts is that of a statement being a logical consequence of some other statements. So, yun po. So first is the connectives. Connectives, also called sentential connective or propositional connective, is logic, a word or group of words that joins two or more propositions together to form a connective proposition. Commonly used connectives include but, and, or, if then, and if and only if. The various types of logical connectives include conjunction and disjunction, disjunction or negation or not, conditional, if then, and biconditional, if and only if. So in a conjunction, two or more propositions that are stated is true at the same time are joined by connective. And as in the statement, life is short and art is short. So ano po yung end? In a sentence such as, if the weather remains mild and there is no frost, then there will be a good harvest. So yun po ang sa ano, conditional. Okay, nandun po yung if and then. So sa the connective is if and then. Yun po yung ginamit. The, the premises and conclusion of a syllogism, syllogism, syllogism. The premises and conclusions of a syllogism are also joined by connectives. As in all all men are mortal and no gods are mortal, therefore no men are gods. So yun po ang salo. So the next is quantifiers. Quantifiers are words, expressions, or phrases that indicate the number of elements that a statement pertains to. In mathematical logic, there are two qualifiers. There exists and for all. There are qualifiers to describe large quantities: a lot, much, many, small quantities, a little, a bit, a few, and undefined quantities, some, any. There are also qualifiers that express the idea of a sufficient amount, or for example, is enough and plenty. So, the monoid is a negation. Sometimes in mathematics, it's important to determine what the opposite of a given mathematical statement is. This is usually referred to as negating a statement. One thing to keep in mind is that if a statement is true, then its negation is false. And if a statement is false, then its negation is true. In logic, negation, also called the logical complement, is an operation that takes a proposition to another proposition, not written or yun po, not written or. It is interpreted in intuitively. It is interpreted intuitively. Negation is thus uh, it is interpreted intuitively as being true when is false and false when is true. Negation is thus an binary single argument logical collective. So yun po. Pag pag false daw yung statement, ibig sabihin yung negation is true. Kapag true naman yung statement, the negation is false. Parang ganun lang po. And the last but not the least, is variables. In mathematical logic, a variable is either a symbol representing an unspecified term of the theory, ito po, and or meta variable, or a basic object of the theory, which is manipulated without referring to its possible in intuitive interpretation. Mathematical variables are letters or symbols that represent numbers that can change. They are often used in algebra expression and equation. Although variables are used in algebra, the concept should be introduced much early while students are in elementary school. So different types of variables is independent and dependent variables, active and attribute variables, continuous, discrete, and categorical variable, and extraneous variable and demographic variables. So yun po. Um, Yun lang po. Thank you.
Formality. Formality of language is an expression is completely formal when it is in the context. This means that in mathematics, we're always dealing in a formal way. The major parts of formality. Definition. Definition is a formal statement of the meaning of a word. Example, a right triangle consists of two legs and a hypotenuse. Theorem. How does the statement translate its negation? Example, Roderick attends mathematics class. It could be Roderick will not attend math class or false that Roderick will attend math class. Conjunction. Two statements are combined by word and. For example, first statement, Ernesto is handsome. The second statement, Ernesto is rich. Connecting these two statements, Ernesto is handsome and Ernesto is rich. Disjunction. Two statements can be combined by word or. Example, life is beautiful. Life is challenging. Combining these two is life is beautiful or life is challenging. Conditional. Notice the word used is if then. It states that a true statement cannot imply a false statement. For example, if x is positive, then its square is also a positive. Biconditional. It uses a connector for two statements using if and only if. Example, our first statement is I will attend mass. Second statement, tomorrow is Sunday. If you combine this, it forms a new statement, I will attend mass if and only if tomorrow is Sunday. Next is corollary, a proposition that follows with little or no proof required from one already proven. An example of this is a theorem in geometry that angles opposite two congruent sides of a triangle are also congruent. A corollary to this statement is that an equilateral triangle is also equiungular. Lemma. Lemma is a short theorem used in proving a larger theorem. For example, Pythagorean theorem is about triangles that can be summarized in an equation x squared plus y squared is equals to z squared. The last part of formality is conjuncture. Conjuncture is a proposition which is consistent with known data but has neither been verified nor shown to be false. It is synonymous or identical with hypothesis, also known as educated guess. We can only disapprove the truthfulness if found at least one false statement. Example, 75 different balls in Mingo. Urn label 1 to 75. Turning to statement, all number in an urn is a counting number from 1 to 75.
Is our support for a solution. When we reason out our solution, we normally use one of two methods, inductive reasoning or deductive reasoning. The inductive is a style of reasoning which draws a conclusion from the valid examination of specific examples. May or may not be valid. It is simple since we infer the solution based on example provided. I usually use inductive reasoning in a mathematical problem. I always search for an example to the topic I am working on, and it's difficult for me to finish a problem without it. Here's an example I found on Google to support an inductive reasoning. First, in the past, ducks have always come to our pond. Therefore, the ducks will come to our pond this summer. Second, Denver is a smart student, therefore he is an honor student. Finally, a math example which I discovered in module, so perhaps this will be the most evident illustration of inductive reasoning. So 5, 10, 15, 20, 25. So what is next? We naturally assume that the answer is 30 because the difference between the number is 5 between the numbers. Thus, we infer that it is 30. It is an example of inductive because we automatically think that the next for the 25 is 30. Deductive reasoning is an inverse of inductive. It involves not simply predicting based on samples but also locating formulae and bases to get the precise solution. For example, if A is equal to B and B is equal to C, then A must be equal to C. Example 2. If 1 dime is equal to 2 nickels and 2 nickels is equal to 10 pennies, then 1 dime is equal to 10 pennies. Number 3. If A is equal to B, then B can be used in place of an any statement. For example, if x is equal to 5, we may replace 5 for x in the equation y plus x plus 2, resulting in y is equal to 7. The deductive reasoning requires comprehension. All I know is that it has formula. A problem solving, at first glance, it appears to be chaos, but attention allows us to reason it out. All I understood is that there is an equation that A is equal to B and B is equal to C, then A must be equal to C. Try to substitute the problem in this formula. You will be able to get an accurate answer. Logical intuition is a collection of instinctual foresight. And in simple words, it is the ability to solve mathematical problems efficiently. Unlike logic, intuition requires little effort and does not compete for central working memory resources. It is the feeling in your gut that tells you that something you are doing is correct. In mathematical intuition, for example, when people talk about acquiring geometric intuition, they mean having a feeling for how curves, surfaces, and so on. When intuition reasoning, it is a logical instinct to get an answer. For an example of intuition, mathematical intuition, when we walk into a coffee shop, we recognize a cup as something we have seen many times before. We also understand intuitively that it is likely to be hot and easily spilled on an even surface. Of course, it's a coffee shop, so it is intuitively thought. And the next example is how many nines are there in between 1 to 100? To think of it, I don't know the answer, but between 1 and 100, the digit 9 occurs in 9, 19, 29, 39, 49, 59, 69, 79, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, and 99. Some smart kid really knows this. So the digit occurs 20 times between 1 and 100. 9 occurs 20 times. Mathematical proof. Mathematical proof is a method of demonstrating the truth of a mathematical theorem. Axioms or theorems that have already been proven to be true can be used to prove a statement. It is a vital note that there is no perfect proof. A theorem may be produced using several procedures, none of which are superior or inferior as long as they are all valid. A mathematical proof is an interpretive argument for a mathematical statement that demonstrates that the provided assumptions logically ensure the conclusion. A mathematical proof can be either direct or indirect. In a direct proof, statements are utilized or used to demonstrate that the conclusion is correct. A proof by contradiction is an indirect proof. It contradicts, I think, a statement that is indirect proof. Direct proof can be used to prove that the sum of two integers is always even. Consider two even integers x and y. Since they are even, they can be written as x equal to a and y is equal to b, respectively, for some integers a and b. Then the sum is x plus y equals 2a plus 2b is equal to 2a plus b. I didn't understand that one. A famous example of a proof of contradiction is the square root of 2. that they say it is an irrational number. Suppose that square root of 2 is a rational number. Then it could be written as in the lowest terms as square root of 2 is equal to a over b, where a and b are non-zero integers with no common factor. Thus, b square root of 2 is equal to a. Squaring both sides yields 2b squared equals to a squared. Since 2 divides and Since 2 divides the expression on the left, 2 must also divide the equal expression on the right. That is, a squared is even, which implies that that a must also be even, as seen in the proposition above. You didn't see any proposition. So we can write a is equal to c, where c is also an integer. Substitution into the original equation yields 2b squared is equal to 2c parenthesis squared is equal to 4c squared. Dividing both sides by 2 yields b squared is equal to 2c squared. But then, by the same argument as before, 2 divides b squared, so b must be even. However, if a and b are both even, they have 2 as a common factor. This contradicts our previous statement that a and b have no common factor, so we must conclude that square root of 2 is an irrational number. To phrase, if one could write square root of 2 as a fraction, this fraction could never be written as lowest terms, since 2 could always have factored from numerator and denominator. My mind exploded. My mind just exploded. Mathematical knowledge consists of those mathematical propositions. Problem solving. George Polya, 1887 to 1980. The birth and date is wrong. I'm sorry. George Polya was one of the most modern mathematicians to research problem solving. He was born in Hungary and migrated to the United States in 1560. Polya's 4 steps are deceptively simple. To become a good problem solver, it helps to examine of these steps and determine what is involved. Polya's fundamental problem-solving method include the 4 steps listed below, which are understand the problems, number 2, devise a plan, number 3, carry out the plans, 4, review the solution. In short, first is to understand, number 2 is to translate, 3 is to solve, and 4 is to check and understand. We need to know exactly what the deal is before we can start to address it, and we should concentrate a significant amount of thought and resources to comprehending it. And because today's problems are so complicated, we know that breaking them down into individual components would not fix them. Consider the following questions. Can you rephrase the issue in your own words? Is there any knowledge or lacking that, if known, would help you to address problems? What is the objective? Those are the key questions to understand the problem. Number two, devise a plan. Creating a plan entails transforming or translating an issue into intelligible inquiry. When attempting to solve an issue, competent problem solvers employ a number of strategies. Try to make a list of facts and what is required to create a plan. Make a well-organized list of all alternatives. Make a table, a chart, or diagrams to organize your thoughts, and then make a guess and double-check it. Number 3, carry out plan. Basically, carrying out a plan is doing something you've planned or decided to do, even if you're not sure you want to do it. Do everything as planned, work carefully, make an exact and clean record of your attempts, and understand that some of the process may not work, but you must innovate and continue. Carry out the plan that you devised. Number 4 should be review the solution. I was wrong. Sorry. So, review the solution. Plug in each value from the replacement set and evaluate both sides of the problem to discover the solution set from the replacement set. If the two sides of the equation are equal, the equation is true, and the value is a solution. Once you've identified a solution, double-check it. First, make sure the answer is consistent with the facts of the problem. Then, interpret it in the context of problem. And last, ask yourself whether there are any generalizations of the solution that may apply to other problems. Problem solving with patterns. A pattern is described as a recurring occurrence or something that follows to a specific rule. Patterns may be used to answer arithmetic problems in a variety of ways. The following are two processes that are always engaged in pattern based issue solving: identifying patterns that your data appears to take on. Then, there are several approaches to finding patterns in issue resolution, and understanding and comprehension are essential. I'm about to present an example of problem solving with patterns in terms of sequence. Unordered numbers such as 2, 5, 8, 11, 14 ellipsis is known as sequence. The first term in the series is 2, and the second is 5, and so on. The last term visible in the sequence is 14, and the following three dots shows that the sequence continues beyond 14. It is commonly practiced to use subscript notation to denote the nth term of the sequence. So, the difference of 2 and 5 is 3, and the same as the number 5 and 8, and so on. The next number that in the last term is 17. In conclusion, the first pattern difference is 3. Problem solved at the first difference, because the difference is 3. And there is a sequence in which their first differences are not the same. If you encounter this, try to. Their first differences are not the same. Find the difference on the first differences, which they refer to as second difference. Example: there is a sequence in 5, 14, 27, 44, 65, and ellipses. Their first differences are 9, 13, 12, and 21. They are not similar. So,
Recreational problems using mathematics. Recreational mathematics is inspired by deep ideas that are hidden in puzzles, games, and other forms of play. Examples of these are Sudoku or Monopoly, or any number of card games requiring addition and subtraction.
Representing data using graphs and charts. What is data gathering? Data collection is the process of gathering and measuring information on variables of interest in an established systematic fashion that enable one to answer stated research questions, test hypotheses, and evaluate outcomes. Ang data gathering daw ay ang pagkokolekta ng mga impormasyon tungkol sa iyong topic. Halimbawa, tungkol sa COVID-19. Ang mga kukolektahin mong data is related din sa COVID-19 kasi hindi naman pwedeng tungkol sa bagyo o sa ibang topic ang kukolektahin mong data. Data gathering methods. Ang data gathering ay may iba't ibang methods. Interviews, questionnaires and surveys, observations, documents and records, focus groups, and oral histories. When we say interviews, it is the way of collecting data through verbal. And when we say questionnaires and surveys, it is the way of collecting data through papers. Data presentation. Data presentation is defined as the process of using various graphical formats to visually represent the relationship between two or more datasets so that an informed decision can be made based on them. Ang data presentation daw ay ginagamit para ma-visually interpreted ang isang data at para mas maintindihan ito ng mga mambabasa. Data presentation can be shown through bar graph, line graph, pictograph, pie graph, and histogram. Bar graph. A bar graph is composed of discrete bars that represent the different categories of data. The length or height of the bar is equal to the quantity within the category of data. Bar graphs are best used to compare values across categories. This is the example of bar graph. As we can see in the picture, we can see the number of people born from the month of January to December. Line graph. A line graph displays the relationship between two types of information, such as the number of school personnel trained by year. They are useful in illustrating trend over time. This is an example of line graph. Pie graph. A pie chart is a circular chart used to compare parts of the whole. It is divided into sectors that are equal in size to the quantity represented. For example, in grade calculation, we can see in the picture how it divided into 5 sectors. Histogram. A histogram is a graphical representation that organize a group of data points into user-specified ranges. Similar in appearance to a bar graph, the histogram condenses a data series into an easily interpreted visual by taking many data points and grouping them into logical ranges or bins. Ang histogram daw ay magkasing tulad lang ng bar graph, pero mas nai-interpret nito ang isang data kaysa sa bar graph. This is the example of an histogram. It is just like an bar graph, but as we can see, it is more compressed. Measure of central tendency. There are three main measures of central tendency: the mode, the median, and the mean. Each of these measures describe a different indication of the type event and central value distribution. Mean, or average. It is the most popular and well-known measure of central tendency. It can be used both discrete and continuous data, although its use is most often continuous data. The mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset. This is the process of getting the formula of the mean. This is the mean symbol, or pronounced by x bar, and the x of 1 is the data value, and n is the number of data value. And this is the sigma, or sigma notation. Sigma is the sum of all values. And this is the final formula of the mean. Mean is equals to summation of x over n. The median. The median is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by outliers and skewed data. Ang median daw ay makikita sa gitna ng mga data. If the given data is an odd number, for example, 65, 55, 89, 56, 35, 14, 56, 55, 87, 45, 13. The first thing we should do to the data is rearrange the data from least value to greatest value. So let's rearrange the data. 14, 35, 45, 55, 55, 56, 56, 65, 87, 89, and 90. So, as we can see, 56 is the middle or the median. The given data is an even number: 65, 55, 89, 56, 35, 14, 56, 55, 87, 45. The first thing we should do to the data is to rearrange the data from least value to greatest value. So let's rearrange the data. 14, 35, 45, 55, 55, 56, 65, 87. So there are two median in this example. If there are two median in the given data, we have to take the 5th and 6th scores in our dataset and average them to get the median of 55.5. If we have a 2 median in the given data, we should add it and divide it into 2. So we can get the median. The mode. The mode is the value that appears most frequently in the dataset. A set of data may have one mode, more than one mode, or no mode at all. Ang mode daw is yung number na inuulit-ulit sa data. For example, 3 and 9 is the mode of this given data. 6 is not mode because 3 and 9 are more frequently appear in the dataset. Features of dispersion. Measures of dispersion describe the spread of the data. They include the range, standard deviation, and variance. The range of a set of data is the difference between the largest and the smallest values. For example, in this picture, 9 is the highest value and 3 is the lowest value of the data. So, 9 minus 3 is equal to 6. 6 is the range of the data. Variance. Variance is the measurement of the spread between numbers in a data set. Variance formula. S squared is the variance symbol. S squared is equals to summation of quantity x minus mean squared over n minus 1. X is the value, is the given value in the data, and n is the number of value in the given data. Table on how to get the variance. So as we can see, mean is what we need in this table. After completing the table, we should get the summation of the result of x minus mean squared. Then substitute it to the formula. S squared is equals to 10.84 over 6 minus 1 is equals to 2.17. So the variance is 2.17. Standard deviation. A standard deviation is a measure of how dispersed the data is in relation to the mean. Low standard deviation means the data are clustered around the mean, and the high standard deviation indicates data are more spread out. Formula of the standard deviation. It's just like the formula of the variance. It's just the square root of the variance. Standard deviation is equals to the square root of summation of the quantity x of initial minus mean squared over n minus 1. Just like in the variance, we also need the table and the mean to know and to find the standard deviation. Measures of relative position. Measures of positions give us a way to see where a certain data point or value falls in a sample or distribution. A measure can tell us whether a value is about the average or whether it is usually high or low. 3 types of measuring relative position. Percentile. A percentile is a measure used in statistics indicating the value below which a given percentage of observations in a group of observations fall. For example, the 20th percentile is the value below which 20% of the observations may be found. The 25th percentile is also known as the first quartile. The 50th percentile as the median or second quartile, and the 75th percentile the third quartile. In general, percentiles and quartiles are specific types of quantiles. For example, arrange the score in an increasing manner. Find the 20th percentile. The percentile value is percentile is equals to n multiplied by I over 100. Quartile. A quartile is a statistical term that describes a division of observations into 4 defined intervals based on the values of the data and how they compare to the entire set of observations. Just like what I've said before, first quartile is 25th percentile. Z-score. A Z-score describes the position of a row score in terms of its distance from the mean when the measured in the standard deviation units. The Z-score is positive if the value lies above the mean, and negative if it lies below the mean. This is the Z-score formula. Z is equals to x or the score minus mean over standard deviation. In calculating Box and whiskers plot. A box and whisker plot is defined as the graphical method of displaying variation in a set of data. In most cases, a histogram analysis provides a sufficient display, but a box and whisker plot can provide additional detail while allowing multiple sets of data to be displayed in the same graph. This is the box and whiskers plot. From maximum to quartile 1 to median to quartile 2 and quartile 3 to maximum. The minimum value is based on the given data and the maximum value is based on the given data.
Probabilities and normal distribution. Each dataset or distribution of scores will have their own mean, standard deviation, and shape. Even when they follow a normal distribution with a mean of 0 and a standard deviation of 1 is known standard normal distribution or a C distribution. Every score in a normally distributed dataset has an equivalent score in the standard normal distribution. This means that the standard normal distribution can be used to calculate the exact percentage of scores between any 2 points on the normal curve. Raw and z-scores. Raw scores are the original scores that are direct results of the measurement. However, they do not provide information about the position of the score in the distribution. For example, a score of 5 on an example does not indicate how well a student performed in relation to his or her classmates. Z-scores, also called standard scores, are transformed raw scores used to compare with normal distribution. To calculate the z-scores, this is the formula that we're going to use. Z is equals to x minus mean divided by standard deviation. For example, z is equals to 26 minus 50 divided by 10, which is 26 is the x, 50 is the mean, and 10 is the standard deviation. This is equals to negative 2.4. The raw score is 26, while the z-score is negative 2.4. Transforming the z-score back into raw score, you're going to multiply the z-score by the standard deviation above that as 10. So, negative 2.4 times 10 is equals to negative 24. And then, you have to add it in in standard deviation, scoring to negative 24 plus 50 is equals to positive 26. Linear regression and correlation. Least squares line, linear correlation coefficient. Correlation is defined as the statistical association between two variables. It exists between two variables when one of them is related to the other in the same way. This is an example of correlation between two variables. In this example, we use a scatterlope. Scatterlope is the best place to show the correlation between of the two variables. If there is no pattern shown in scatter plot, then their relationship has no correlation. Pardon me for the wrong pronunciation of scatter plot. Well, this is if the point in scatter plot shows somewhat straight line pattern, the relationship is a linear, and this is what we will examine. Linear correlation coefficient. We use the linear correlation coefficient to quantify the strength and direction of the relationship between two variables. We're going to use the formula R is equals to the summation of x sub 1 minus x multiplied by y sub 1 minus y divided by s sub x and s sub y, overall divided by n minus 1, where x bar and s sub x are the sample mean and y bar and s sub y are the mean and the standard deviation of the ys. The sample size is the n. These are the alternate computation or the other formula to compute the correlation coefficient. The linear correlation coefficient is also referred to the Pearson's product. This statistically numbers describes how strong the linear relationship of the two variables in the direction, may it be positive and negative. Now that we have identified two variables that are correlated, we want to use one variable as a predictor or explanatory variable to explain the other variable. The response or dependent variable in the other. To do this, we need a good relationship between our two variables. A strong relationship between the predictor variable and the response variable leads to a good model. A simple linear regression models allows us to predict a response for a given predictor value. Here are some examples of the simple regression. The equation is given by y is equals to b0 plus b1x, where b sub 1 is equals to r multiplied by sy divided by s sub x. To compute the residual, you're going to use the observed minus predicted. A negative residual indicates that the model is overpredicting. A positive residual indicates that the model is underpredicting. In this instance, the model overpredicted the chest girth of a bear that actually weighed 120. Here is an alternate computation equation for the slope.